Aloha, everyone. My name is Julia Wicklund, and I'm the moderator for this session titled Permanent BMP Manual Requirements. Please use the Q&A section during the presentation to ask any questions you may have. At the end of the presentation, we'll have a few minutes for our speaker to answer your questions. Without further ado, I'd like to introduce the speaker for this session. Richard Price is a professional engineer with over 25 years experience in stormwater and sustainability design and implementation. Richard currently works at EA Engineering and is EA's Pacific Region Sustainability and Stormwater Program Manager, serving clients up and down the West Coast and around the Pacific Rim. He has worked with the Department of Transportation for more than 10 years, supporting the Municipal Stormwater Permit Compliance Program. His experience includes erosion and sediment control, stormwater treatment and design, and LID project development, as well as climate change and sea level rise risk assessment and mitigation strategy development. Richard is an APWA certified stormwater manager, a SISEC certified inspector of sediment and erosion control, and a California qualified industrial stormwater practitioner. Everyone, please help me in welcoming our speaker, Richard Price. Good afternoon, Richard.
Thanks, Julia, and hello, everyone. Good afternoon. This session is going to be on the permanent BMP manual requirements, and I think many of you know the permanent BMP manual was first put out by the Oahu district, but it is a statewide stormwater program, so it is applicable across the state. Quick agenda, we'll do a brief introductions. We'll talk a little bit about the details of the permanent BMP manual, and then I'll give a little more insight and thoughts on low impact development, and then we'll close out and entertain any questions you may have. Julia did an excellent introduction, so I don't need to tell you too much about myself. I lived in Hawaii for 2 years when we started the DOT project in 2009 and 2010. And since that time, I've been in Seattle and travel back and forth to Hawaii as needed. This year, I have not been since January, and don't imagine I will be there until sometime next year, but we'll all keep our fingers crossed and move forward. My background is in construction management, as well as stormwater, and I've been managing large stormwater MPDS programs since 2002. And you have my email address there. If you ever need to get in contact with me, feel free to reach out at any time. And this is the part where I normally ask you who you are. And so let's try and use the raised hands feature here briefly. And we'll start off with how many engineers do we have? Okay, 23. How about contractors? About 10. How about consultants? Pushing 20 there. And how about everybody else? Eight, 9. Okay, so that sort of rounds us out. And again, I would normally ask what your stormwater background is. I'm going to assume you're all here because you're working in and around the stormwater realm and have an interest in what we're here for today. And in terms of what you want to learn from the class, I'll tell you what my goals are, is to provide a little overview of the permanent BMP manual and how we do some of the calculations in the manual, and then give sort of an overview of low impact development and how it may be beneficial for some of your projects in Hawaii. So the permanent BMP manual is, as I said, it's applicable across the state of Hawaii. And it was last updated in April 2015. As many of you know, the Oahu district received a new permit this fall, and probably based upon that permit, there'll be a review and at least potentially an update of the manual in the upcoming year and a half. Don't know exactly what will come, but we will work from what we have right now, and be interested to hear any thoughts you have on the future of it. The manual lays out, where it's applicable, exemptions and variances, talks about project planning, project design. There's a permanent BMP checklist that you can use on your projects, and the review and approval process. And as most of you probably know, the permanent BMP manual is available on stormwaterhawaii.com. So the bottom line, what does the manual require? Projects that generate 1 acre or more of new impervious area must incorporate low impact development stormwater controls. And there's some exemptions and variances from that, but basically that is the rule. If for whatever reason low impact development is not feasible at a project site, then we would revert to more traditional stormwater treatment. So the way the review process works, actually, any project that disturbs 1 acre or more of land is reviewed for the need for BMPs. And as I mentioned on the last slide, if there's greater than 1 area of new impervious surface, it triggers a requirement for low impact development permanent BMPs. There's also thoughts for smaller projects, less than 1 acre, that have the potential to discharge pollutants to the MS4, and they may be required to install specific BMPs. And we'll talk a little more about that later. There is also at least the potential that there may be a project that disturbs 1 acre of land that maybe doesn't have a full acre of new permanent impervious surface that could be required based upon specific site conditions, the waters that you discharge to, or other, site specific and project specific information. So, as I said, if you reach the trigger, you're required to install LID. However, some projects may qualify for exemptions and variances. And that's where we revert back to more traditional permanent BMPs, which may be proprietary devices or some other form of treatment that's appropriate. So in terms of exemptions, if you have a project that is returning an area to pre-development hydrologic conditions, if you are not discharging to state waters, and my understanding of the interpretation of state waters in Hawaii is that pretty much every square inch of land on the islands is state water. So that one I won't say never apply, but rarely applies. If you are doing operation and maintenance activities such as pavement repair, pavement resurfacing, and base yard repairs. There's also an exemption for linear utility projects. This would be guardrails, installation of, power, water, these kind of linear utilities. And then water quality improvements. So for instance, if we are building a stormwater treatment project, it can't then trigger the requirement that you install more treatment because you because you actually built something to improve the water quality. And then obviously for emergency projects, there is also an exemption. There are also some variances based on hydrogeologic constraints, physical constraints, operational constraints, and others. And these I'll run through in a little more detail. So hydrogeologic constraints. Most of our low impact development features depend upon infiltration. And to have infiltration, we need soil permeability. So if the soil has a permeability of less than ½ an inch per hour, there would be a variance from installing an infiltration device there. Similarly, infiltration devices do not function properly if they are discharging directly into groundwater. So if your seasonal high water table is within 3 feet of the bottom of your BMP design, you would be it would be applicable for a variance. Similarly, there's a distance, a setback from groundwater wells or septic systems, also from building foundations or road beds. And then another major concern is slope stability. Where I live in the city of Seattle, the city maintains a very detailed GIS map of all the steep slope areas, and there is a 50-foot setback at the top of those slopes, because if you were to infiltrate a large volume of water at the top of a slope, you can supersaturate the soils and cause instability in the slope. It will cause a slope failure. There was several years ago, they had the Oso landslide, where the whole hill came down and blocked the river and destroyed an entire neighborhood in Washington. And there was some thought that that was caused by a logging project at the top of the hill that clear cut an area and increased the infiltration at the top of that hill and saturated the hill slope. So it's a significant and real risk that we want to avoid. And then sensitive downstream areas. If there is a downstream habitat that could be impacted by the BMPs, there would be a variance applicable as well. So in terms of physical constraints, there may be space constraints. The DOT right of way is always confined. Most typically, we're trying to add lanes within an existing right of way, so there's even less space available. Many times we don't have the space to treat the entire treatment volume that we're looking for. Site slope, again, even if it's may not be so steep to cause stability issues, but we don't have enough, flat or flattish land where you can site and design and build an infiltration project. Again, lack of right of way. We don't want to build next to other people's property line where we could cause infiltration and water impacts on other people's property. Contaminated soils. If the project is in an area where of known subsurface contamination, or if we take soil samples and find contamination in the design phase, there would obviously be a variance. We wouldn't want to infiltrate water into contaminated soils. And then sensitive community sites like a wildlife refuge or those kind of things we don't want to impact. Similarly with archaeological sites. And then there's operational constraints. The loading requirements of pavement, we want to stay 10 feet or more from the pavement of the roadway. No application of water for reuse. There's not really a lot of opportunity for reuse in the DOT projects, and so typically it's not pursued. And hazardous operations. This can take a lot of forms, including some of our road safety setback requirements. We need space for cars to safely leave the roadway and not impact, and we need sight lines and some of these things. So we don't want to create a hazardous situation for people driving. And then obviously, if building something would violate federal or state law, we would not want to construct in that area. So when we come to the implementation, I mentioned the design volume. There was a fair bit of research done and arrived at a statewide standard of the 1-inch design storm. So the way we apply this is a 1-inch rainfall over the area of not of your project, but of the drainage area draining to your discharge point. And, so that water quality design volume is equal to C times the 1 inch of rain times A times the 3630. C is a runoff coefficient. We'll talk more about that. A is the area of the drainage in acres, and the 3630 is a conversion factor. And the 1 inch, as I said, is our design storm. So just as an example, from the permanent BMP manual, we have suggested values for the runoff coefficient C, and it varies not only by surface type, but also by slope. You'll notice that the steep grass area is 2-to-1, which is an awful lot of the embankments alongside our roadways, has a fairly high runoff coefficient as compared to a turf meadow, for instance. So we need to take that into consideration. It's important that you design for the total volume that you're going to receive. And this often includes water from outside the right of way, because if you only design for your project area or for the DOT right of way that drains to your discharge point, in a larger storm, the additional water from off-site is going to overwhelm your BMP and may cause erosion issues and any number of problems with that. So you calculate your design volume, you collect site data with soil type, depth of groundwater, typically conduct a percolation test to get your infiltration, and then research of the site history, particularly with an eye towards underground utilities and potential for contaminants in the subsurface. And armed with that information, you're then able to start the process of designing an infiltration BMP that will store and detain, evapotranspirate, and biotreat your water quality volume as designed. So again, once the 1 acre new impervious area is established, you design for LID. If you realize that you're not able to treat the full volume using LID, maybe because of space constraints or part of the site doesn't have the adequate infiltration rate, often we will treat the additional volume using alternative or traditional BMPs. So we may treat some of the design volume with LID, and then treat the balance with a proprietary BMP or some other type of sand filter or something that would get us to our water quality design volume. And obviously, if you come across these constraints that you think may require a variance or alternative BMPs on a project, consult with DOT highways before you proceed and make sure that we're all on the same page and moving forward with the best possible design concept. So I mentioned the smaller projects, less than an acre, and we identify projects that have potential to pollute, that we want to apply source control BMPs. Such projects include gas stations, auto repair shops, restaurants, projects with parking lots with at least 10,000 square feet. Some of your large box stores. And I'd be interested if anyone can comment. And I guess I can't see the Q&A. If anyone could comment, now I can. Okay. If anyone could comment in the Q&A, what type of source control BMP might we put on a gasoline station? Or a restaurant? Any ideas? An oil water separator, that would be excellent for a gasoline station. Or a fog trap for the restaurant. Exactly, the fats, oil, and grease, the grease trap that restaurants were required to have by the health department. So that's exactly what we're looking for. So thank you. Operator error. Okay. So again, coming back to the applicability of this manual, it applies to contract and in-house projects and encroachment projects. Basically, any project that is going to disturb more than an acre of ground should be reviewed, and the requirements of the BMP manual applied accordingly. And there are some special conditions for sensitive receiving waters, which are some of your class 1, your class AA, and then selected 303D list water. So that includes the TMDL watersheds as well as other watersheds that have been listed and may not yet have a TMDL, but there may be concerns about future TMDLs and the need for additional treatment on those projects. So the project planning phase, we want to consider the permanent BMPs during the early stage of the project. Typically you'll know early on whether you're going to be required to include these BMPs, and you'll want to include them as part of the original design package so that you can move forward with the planning and organization. One of the biggest complaints I get about requirements like this manual that requires you to include stormwater treatment is that it's too expensive. We didn't know about it. We didn't include it in our budget. We don't have time to design it and get it included in the bid package. And all of these can be avoided by some good project planning and upfront organization. For instance, when your geotech is out taking soil samples for the roadbed, they can also be collecting the soil samples for permeability analysis so that you can kill two birds with one stone, so to speak, and save having to send someone out again to do another analysis. So the early planning, incorporating it early in the project, avoids a lot of these traps and cost overruns, and allows us to move these forward as part of the project. I love to preach. I know it's not part of the road, but it's part of the project, and it's just as important as the concrete, and it's just as important as the signage and the traffic signals. The stormwater treatment is an integral part of the overall project. So in the development process, you're going to need to identify where your outfalls are and where's the best place for treatment. Develop your permanent BMP footprints. If you're doing an infiltration device, the size is going to be driven by your treatment volume as well as your permeabilities, which is then going to drive, how much space do we need? Do we have it in the right of way? How can we adapt to that? And obviously prepare a preliminary cost estimate so it can be incorporated in the project and move forward. I just included this slide because I think it's interesting when we're talking about permeabilities. Um, you know, when you get into your silts and your clays, there really is, you know, little to no infiltration that's going to happen. And there are areas in Hawaii that might reach this 200-year number, and then on the Big Island, there's lots of 2-minute infiltration. So you you've got the full spectrum to work with. And we talked somewhat about these design constraints, but you know the topography can be important. Most of these infiltration features need to have a relatively, even like a grass swale, needs to have a relatively low slope so that the water has time to be treated by the grass and to infiltrate and get the treatment that you're looking for. So if it's really steep, or you know we're building roadway right to the edge of the right of way, or we have roadway right to a, a steep embankment. Um, uh, and then this third one I left in here, the construction budget, but I will remind you, if you were to ask the EPA, they will tell you that under the Clean Water Act, lack of funding is not an excuse for noncompliance with the requirements of your permit and related documents like your permanent BMP plan. And then quickly, I'll touch on life cycle considerations because, you know, again, oftentimes people say that LID can be more expensive, but I think you will find if you look at it over the full life of the device, the maintenance cost can be significantly lower for low impact development, and those annualized costs over time can become very significant. You know, the cost of, if you have a vault that you're going to go and bring a vac truck and suck it out 2 or 3 or 4 times a year for 20 years, and you start adding those costs onto construction costs, you may find that a rain garden or a bioswale compares very favorably from a cost perspective. So let's take, how are we doing on time? Yeah, we got, let's take a little time and go through some LID features. First some definitions and then some examples, and maybe a few specific projects in Hawaii. So what is LID? Low impact development. Some places now they're calling it green stormwater infrastructure or green infrastructure. Environmental site design is more related, I think, to sort of subdivision type development, where they talk a lot about site fingerprinting and the idea of only disturbing as much land as needed. Not as applicable to linear projects like roadways, but can be, because the concept of the less you disturb, the less you need to treat is always beneficial. So what is LID? The Water Environment Research Foundation says it's a comprehensive land planning and engineering approach with a goal of maintaining and enhancing the pre-development hydrologic regime. Another good example is that it's a strategy to control stormwater quality at its source, incorporating such elements as infiltration, retention, and biofiltration. And this is a common theme. And in terms of roadway projects, what it comes down to is installing more smaller treatment sections rather than one big one. If we wait and collect all of the water at the end of the pipe, the treating that kind of volume, it can be done, but again, it requires a lot more land area. And typically we don't have that at the outfall or our discharge point. So looking at things like bioswales or dispersed smaller treatment sections can provide us the necessary treatment, and can also serve as an aesthetic element with the proper landscaping, particularly in areas of pedestrian traffic. And then this last definition comes from a colleague of mine, but I always kind of liked it, so I thought I'd share. Conventional BMPs are designed to treat the impacts of construction on the environment, and LID is designed to prevent or reduce the impacts of construction on the environment. So we're trying to, again, we're trying to mimic that pre-development hydrology. And I think this slide, there's a kind of a lot of information going on here, but if you look at the one on the top box, in the natural conditions, and I think the real key is down by the lake there, you see 0.3% of the water actually runs off as surface runoff into the lake. And this is common throughout most forest types, between the infiltration, the interception and evapotranspiration off of the trees and vegetation, and especially what they show as interflow, because what moves through the near surface soils, which tend to be more permeable. And then if you look at the lower one, when we come in and urbanize an area, lay down a lot of asphalt and concrete, we get much less discharge to groundwater and much more surface runoff. And of course, that surface runoff is what's transporting pollutants off of rooftops, driveways, pavement, interstates, and carrying those pollutants directly into our storm drain, directly to our outfalls untreated. So the more we can do to mimic this, the top condition where we're infiltrating this water to the inner flow and the groundwater, and capturing it and holding it for evapotranspiration, the less total runoff we have, and obviously the better for all of us. So what is LID? I've just put together a list of types of devices here. Probably most applicable for highway projects is your rain gardens, bioretention and bioswales, infiltration basins. Vegetative buffers can play a big role in places where we can avoid concentrating flow into a point source, but rather through use of a level spreader or something, and discharge through vegetation off site, so that we disperse the water into the vegetation and allow it to slow down and drop out and filter out pollutants that way. Tree box filters. You see the Filterra device here. It's a stormwater inlet, and it has a highly pervious soil mix in there that will filter the water that goes in, and then obviously a high flow bypass to discharge, and a variety of trees that can go in there. It's an excellent choice in an urban, semi-urban environment. And then I think storage and reuse is probably not as applicable in the DOT's locations. And so why is LID important? I guess you could say it's sort of the new way of thinking about stormwater management. It is very heavily regulatory driven these days. Almost everyone's permit is incorporating it. And you can make the argument that it's a better way of doing things. The more we can mimic the natural hydrology of a site, the more groundwater we can recharge, the better we are in a lot of ways. I guess the reason it's important to you is because it's here to stay and we have to do it. So I think we've talked through this life cycle. It's same steps as any project. The key that I like to stress is incorporating the design and planning of your LID device in your early project planning, so that it's on the same schedule as the rest of your project, and ready to go. The last point I'll add here is your long-term O&M. It's important that you have an operation and maintenance plan, so that when you build these things and install them, that you have a plan to take care of them going forward. It's usually a small part of the overall project, but it is an important part of the overall project, and incorporating it as such makes everything work smoother. There can be challenges. There's stakeholder buy-in. The little rain garden that you see here, I apologize, the picture's not that great. These are notorious for capturing trash. They do a great job of it. Unfortunately, if you don't come and clean it out all the time, all the trash in the parking lot runs right in to the little mulched vegetated area, and people are constantly complaining about all the trash that's collecting there. I think it's better that it's collected there in a place where we can pick it up and dispose of it instead of going down the pipe and into the ocean. But it's a common complaint that we get. We talked about land availability. It's an innovative technique, and this applies all the way down the line, from the design to the construction to the training of your construction inspectors, because when the contractor delivers a bioretention soil mix, have they seen one before? Do they know how to review it and see if it meets the spec? And is it the right thing? And then, like I mentioned, maintenance issues. If it's going to capture trash, we've got to clean it out. So with that, I'll leave you again with a note of where to find the permanent BMP manual on stormwaterhawaii.com. And as I mentioned, stay tuned. There may be an update coming in the near future. The presentation I did today was condensed from I believe a 4-hour training that we've done in the past. I would expect, if we do an update to the manual, hopefully next year we'll be able to plan a more detailed overall training on the manual as a whole, and particularly on any updates. And I'll leave a question for each of you to think about. With everything that you've learned today in all of the sessions, what creative ideas can you come up with to incorporate into your work going forward that's going to help us reduce water pollution coming off of the highway system, help us find sustainable and cost-effective solutions? Again, these things they've got to pencil out for it to make sense. Add aesthetically pleasing design elements to our projects where applicable, and leave the smallest footprint we possibly can. And with that, Julia, I will open it up for questions.
Thank you, Richard, for that very informative presentation. We're now going to enter into the question and answer part of today's session. If anybody has a question for Richard, feel free to type your question in the Q&A section at the bottom of your screen. So we have a question, Richard. What percentage of variances are given?
So I don't have a number off the top of my head. I think there's probably more exemptions than variances, and not that that's splitting hairs. I assume you're asking for both. But the exemptions tend to come more for, like I said, utility projects and direct projects that have an exemption. Variances tend to be more based on site conditions, such as soil permeability, et cetera. I don't have a percentage. I could try and look that up if you want to send me an email, and we could try and get an answer for you.
Are there any other questions? We'll give it a minute to see if we receive any more.
Well, if there aren't going to be any other questions, I will, like I said, leave you with the thought that if we incorporate these projects at the early in the project development process, they don't have to be a hindrance or a significant challenge, and can be effectively and cost effectively incorporated into the project. And if we all work together, I think we can make it the standard everywhere.
We got another question. It says, you mentioned Hawaii state waters are essentially the whole island. Does this vary from the mainland? And if so, what is the reasoning we are different?
There is some interpretation from state to state on that. But in some states they do consider, they list water of the US, not state waters, for one. And if you go with the Corps of Engineers definition of waters of the US, there's a fairly defined set of water bodies and potential wetlands that are interconnected to water bodies that would be considered waters of the US. The reason I think that Hawaii is more cautious, because you have fairly steep mountainous terrain, and pretty much every gully and drainage goes very quickly to a stream that goes very quickly to the ocean. So we're kind of we're all part of the ocean and the water and the land as one.
Do have a few more minutes remaining in the session if anybody has any more questions. Should we expect the BMP manual to be updated anytime soon?
As I mentioned, with the Oahu's new permit, they will be reviewing all of their design criteria and manuals. So it will be reviewed, and for any necessary updates relative to the new permit. And like I said, I would expect that process to happen over the next year to 18 months. Any other questions?
All right, if there aren't any other questions, thank you again, Richard. That now concludes this session. Thank you all for attending and for participating and interacting with today's speaker. The last sessions today begin at 3 p.m. Please return to the sessions tab to see the next breakout sessions.
Thanks for attending, everybody.
And don't forget to visit one of our Department of Transportation public education booths to obtain your conference certificate. Additionally, there will be a post-conference questionnaire available following the last session, which will be worth 500 points upon completion. So make sure to fill that out. Thanks again, everyone, and have a great rest of your day.